All right, we're recording this live. It's always live since Lily is out partying with her homeschool people at the Getty Villa. All right, Lily, we hope you're having a good time, but you have to study afterwards. Okay, any questions on your homework?
Nope. Nope.
Nope. Lily, any questions on your homework? What? I can't hear you, Lily. Can you say that again? Okay. Now, what we're gonna do, if you look at your homework, you will be doing SCT. Okay, Dr.
Oh, great.
Chung. Okay,
I need
tips
to review.
1 through 15. So if you look at
Okay.
your book, there's like 60 tips. So each tip has like a section. You don't have to read. Well, there's a brief explanation, but there's like practices. You have to go through all of them, and then check your answer key in the back. Okay, so these are just like this. This will be a review of all of your Algebra 1 and all of your geometry that you need to do well on your SAT. Okay, and then
So
while
are
you're
you gonna
doing,
post it?
I'm gonna. It's on your iPad. Well, I'll install it on your iPad. Okay.
Okay.
And I think Lily, you said you had your book, so take a picture of it or something, and then just do it on your iPad. Anyways, so while you're doing that, which will review algebra, geometry, and then also practice SAT, we'll start looking at trigonometry in more detail. Okay, so all of you should have your circle memorized. I was gonna do a quiz, but I think we can just move on. All right, so how does this circle work? Okay, so let's basically just write this down. These numbers in this chart is your first quadrant x and y coordinates when a radius of a circle is raised to a certain angle. So you got 30 degrees, 60 degrees, and 90, no, not 90, sorry, 30, 45, and 90.
30, 45, 60?
30, 45, and 60. That's pi over 6, pi over 4, and pi over 3. And so understand that the sine values that you get are your y coordinates. Cosine values are your what? X coordinates. And tangent values are y over x. And later on, you'll learn that tangent is actually another version of your what?
Slope.
Rise over run. Okay. All right, so the numbers that's written in here all are your coordinates. Okay, so that's over 2.
I think it's over 2 for the sine.
Oh yeah. Oh my goodness, I'm like blanking out here. So so this one is 1 over 2, and then for tangent, rad 3 over 3, 1, and rad what? Rad 3. Okay. Oh, one more thing, I've totally forgot. Going back to our unit circle, you'll notice that on top, I don't think I finished explaining all of this, but since your signs are y coordinates, it'll obviously be positive in your first what? Quadrant. In fact, everything will be positive. That's your x. This is y over x. Secant is 1 over x, or 1 over cosine. Cosecant is 1 over what? Sine. And this is x over what? Y. Okay. So basically just understand this. Sine is the same thing as writing as 1 over cosecant of x. Okay. Or just 1 over cosecant. Don't worry about the letters for right now. You know what? Let me slow down. Here we go. So when you have sine, that's basically your y coordinate, right?
Yep.
When you have cosecant, it's basically the reciprocal of 1 over sine. So instead of writing it as 1 over sine, you could rewrite it as what? Cosecant. So if you have 1 over cosecant, you can rewrite this as? Sine. Okay, so sine and cosecant are reciprocals of each other. Secant and cosine are reciprocals of each other. So cosine is 1 over what? Secant, and secant is 1 over cosine. And then tangent and cotangent are reciprocals of each other. Okay.
Okay.
All right. That's all it is. It's just a reciprocal. But instead of writing it this way, you'll write it like that. Okay. So, but in terms of the signage, in terms of the positivity or negativity of the value, because it's just a reciprocal, it's going to be the same thing. So, like in quadrant 2, notice right here, all the y values go up, right? So they're always going to be positive. So sine and cosecant will be what? Positive. Cosine and secant will be negative, and tangent, because it's sine over cosine, it'll be in quadrant 2, y over x, it'll be negative, and that's why it's there. And then on quadrant 3, everything's negative, right? X is negative, y's are negative, so sine and cosine are both negatives. But then negative over negative will create a what? Positive. That's why tangent and cotangent are going to be positive. Does that make sense?
Okay. Yep.
Yeah. And in quadrant 4, the cosine values are x values going this way. That's positive. But you're going to go down, which means all of your y coordinates are going to be what? Negative. So cosine and secant are positive. Sine and cosecant are negative. But then tangent and cotangent are, again, y over x or x over y. So it's going to be negative because one of them will be positive. The other one will be negative. Okay. Does that make sense?
Yes, sir.
Okay, all right. So going back to this here, most of all of your trigonometry, like equations, your manipulations and operations in math, all revolve around these three numbers: 30, 45, 60. The other two are 0 and 90, but those are easy. Those are just on the corners of the circle: 0, 90, 180, 270. So we know what the coordinates are. So you just have to keep that in mind. So these are the numbers that we're just going to be working with. Outside of these numbers, you have to use your calculator to find the actual value. Okay. All right. Now let's just really get into like what exactly all of these things mean. And I think I explained a little bit long time ago. But basically, you have a circle with the radius of 1, and here's your hypotenuse. This is 1 comma what? 0. That's how far the radius is extending. And if you angle the radius up, the size of your radius will not change. That's what a radius means. You can go all the way what? Around. But the question is right over here. If you raise your radius to a certain angle, we'll call it theta, what will that coordinate on the edge of the circle be? Well, generally speaking, it will be cosine theta sine theta. Does that make sense?
Oh.
You get it? Yeah.
Because cosine will give you the height.
Well, let's look at it like this, okay?
Or
if I drew this out, it's another right what? Triangle. Okay. And so if I take the cosine of this triangle of that theta, it's adjacent over what? Hypotenuse. Now, adjacent means up to this point right over here. Okay, that's your x coordinate. So that's x over 1, which is basically what? X. And if you take the sine of this theta, it's opposite over hypotenuse. Well, the opposite is a y coordinate, or y distance upward. So it's y over 1, which is essentially what?
Okay.
So do you see now why cosine theta gives you x, sine theta gives you what? Y. Does that make sense?
Yes.
Okay, so again, let's take a look. If you raise this to 45 degrees, okay, so cosine theta or cosine 45 degrees will give you radical 2 over what? 2. Sine 45 degrees will also give you radical 2 over what?
2.
Wait, do you see how I got that?
Yes, I know.
Because it's on our chart. You get it?
Yeah.
Sine of 45 degrees gives you rad 2 over 2. Yeah. So that means this coordinate right here is basically rad 2 over 2, rad 2 over what? 2. Now, if you type it into your calculator, you'll get an approximation. What's rad 2 over 2? It's, let's see. If you guys have your calculator, go ahead and punch those in. Rad 2 divided by 2 equals, no, that's not it. Rad 2 divided by 2 is 0.707, so 0.71. We'll just do 0.7. 0.7, 0.1.
Okay.
Yeah, so that's the coordinate on that circle. Now, if you extend the radius, if you keep on going over here, let's imagine you went all the way over here to 135 what?
Please.
Yeah, well, think about it like this. We went 135 degrees. We ended up in the second quadrant. Well, what's his reference angle? You see this right here? What's that angle right there?
45.
Yeah, it's 45. Aha, so now, okay, so watch. So in order to compute cosine of, let me make this a little bit thicker. Cosine of 135 degrees, right?
Mm-hmm.
Well, what do we know about this coordinate right here? Now, shouldn't the digits of these two be the same as those two?
Yes.
Because it's a mirror reflection, right? You went up 45 degrees this way. You went up 45 degrees this way. I mean, okay, we're going 135 degrees like that. But in terms of the symmetry, you're going up 45 degrees on both sides. The height should be the same, and the distance from your origin should be exactly what?
The same.
The same. But what do we expect the x value to be?
Negative.
Negative rad 2 over 2, or negative 0. What? 7. And then rad 2 over 2 because it's positive, right?
Mm-hmm.
So grab your calculator and type in cosine of 135, and you'll expect a negative 0.7 as an answer. So let's open up both of these. Okay, so we got, okay, and make sure your measurements are in degree form. Okay, so we got cosine 40, no, not 45, 135. Guess what? We got 0.707. You guys get that?
Mm-hmm.
Okay,
yeah.
So here it is. Okay, see it? Now, notice that the calculator understands which quadrant you're actually what?
In.
Now, if you do it by hand, how would you write this? Well, if you were doing cosine 135 by hand, you realize, okay, the reference angle is 45 degrees. So you'll say, hey, cosine 135 is the same thing as finding the cosine of the first quadrant answer. We call this the reference angle. But because it's in quadrant 2, this is going to be a what?
Negative.
Okay, so this is how you want to write it. Cosine of 135 degrees is equal to negative of cosine what? 45 degrees, which is equal to negative rad 2 over what? 2. So this is how you're supposed to do your math by hand. Okay, you're not going to be using your calculator when it comes to your reference angles. All right, so let's keep going. We went to quadrant 2. Let's go to quadrant what? 3. Let's go all the way what? Over here, right? Actually, let me use a different color. Okay, so now what angle is this right here? How far did we go in this circle? If we're sticking to the 45 degree idea.
235.
225.
25.
Okay, 225 degrees. Okay, so what's our coordinate at 225 what? Degrees. Well, how do we write it? We say cosine of 225 degrees is equal to what? What would you write? Well, the reference angle is still negative what?
45.
Where's our reference angle? Right here, you get it?
Mm-hmm.
You see that? Meaning from the horizontal line, it went down 45 degrees. The y distance and the x distance is exactly what? The same as if we were in the first quadrant. You get it?
Mm-hmm.
Okay. So again, what would you write? How would you write this out in terms of its algebraic format? So you'll write cosine 225 is the same thing as cosine of what?
Negative 45. Yeah.
Yeah. Well, yeah. First okay. I mean, So it's the same thing as the value at the first quadrant, but because it's in your third quadrant, you're going to put a what?
Negative.
A negative. Okay, does that make sense?
Yes, sir.
Yeah, so this would be negative rad 2 over what? Over 2. And the same thing goes for all the other ones. Let's just go all the way around full circle. So now if you go to right over here, and this will be in what, blue color? So go all the way around right here to, great, it made a perfect circle. Well, to, I don't want that. Okay, good. All right, so now how far did we go?
250.
315. Okay, now keep this in mind. You never want to measure reference angles based on the vertical line. So this is not, we don't want this to be 45, even though technically it is. It's always with respect to the horizontal line. Okay, so from here to here is what?
45 degrees.
You guys get it? From here,
Okay.
if you measure like this is 45. This is 45. We don't want to measure it from the vertical poles here. Okay, like that. Okay. All right, so cosine of, let me change the color to, no, I'm sorry, cosine of 300 and what? 15. Okay, is the same thing as
negative cosine.
No,
45. Cosine 45. Oh yeah, cosine.
It'll just 45. Be cosine 45 because the x values in quadrant 1 and quadrant 4 are exactly
positive.
Same. There you go. Okay. Does that make sense?
Yes.
Okay. I think that's good for some practice problems now. Let's see.
Did you post them?
I gotta get. I forgot my mouse.
Oh.
My mouse guy.
Okay, so let's try these. All right, so I posted it right here.
Okay.
And Lily, I'm going to post yours since you're always at the very end. So you can follow along in the video. This is so interactive, right? So Lily, so you can do your work here and then I'll show you what the other ones look like as well. So imagine you're actually here even though you're not, and you can participate. Okay, give me the value of number 10. What is 7 sine of 7 pi over 6? Now, hold on. Mrs. Mine. Okay. Miss Minne. Okay, what you're trying to do right now is just whatever you're trying to do on your own. You're trying to change the radian into what? Degrees. Well, first of all, you cannot write it like this. Okay. So when you have a sine of 7 pi over 6, it's literally a unit. You cannot separate the sine from the 7 pi over 6. So by attaching 180 over pi, thinking you can multiply like that, it's forbidden. You cannot do that, okay? So you cannot write it that way. You have to treat this as if it was one what? One unit. For instance, let me explain. Can you divide this by 7 pi over 6 and go like this?
No.
No, it's like a brick. You cannot cut a brick in half, okay? It's just one brick. Now, if you want to change that to a degree mode, you can, but we don't want to change it to degree modes, okay? We want to stick to radian measures because it's actually much more easier, okay? So let me explain.
Wait.
No, I'm not going to wait. What?
I just realized this is actually on the circle.
Oh, now you realize that?
350. Yeah. Isn't this on 315? No. That one, no, that one's not 315. That one is 210. No, because wait, no, never mind. 210, reference angle 30,
Oh,
be
I'm so bored.
negative.
Okay, look.
Negative.
So
Wait, hold on. I think I got something.
Okay.
Negative.
I don't know if Lily can hear all the background discussion. I don't know if the voice is being recorded. And yeah,
Wait, we want this.
here we go. So basically, 7 pi over 6, guys, think about it, okay? The denominator gives you everything you need to know. It's pi over 6. What has 6 on the denominator as a radian
30
measure?
degrees.
30 degrees. Or it means you cut this into how many parts?
3.
6 parts. 4, 5, what?
6.
So this is 1 pi over 6, 2 pi over 6. So you go 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Aha! 7 6 right over what? Here. Okay, so this is 7 pi over 6. But what's this measurement right here?
2
Pi
degrees.
over what? Pi over 6, which is the same thing as right over what? Remember, pi over 6 is a radian measure. It measures the length of the arc. Like if you're walking on this little arc, it's pi over 6 units long. This right here is pi over 6 units what? Long. But from the origin, we've walked 7 pi over what? 6 all the way here. So the value of this, like if this is the unit circle like that, get it? The coordinate for this should be the same as the coordinate for right up what? Right up there.
Oh, you want coordinates.
That's what we're looking for. Sine of whatever you're given is the y coordinate of that dot on the unit what? Unit circle. So notice right over here, if you went up 30 degrees, well, what do you know about the coordinate at sine of 30? It's 1 what?
It's half.
It's 1 half. So over here, it must be?
Negative 1/2.
Negative 1/2. And that's the answer for this. This is equals to negative 1 what? Half. Easy peasy, okay? What about number 11?
You wanted us to convert to degrees.
Wait, what?
Rad 2 over 2.
No, it's not rad 2 over 2. It's 30. It's 30 degrees. Hello.
Wait, you want
degrees?
Do you want degrees or?
I 참나. Look, sine of 30 degrees or sine of pi over 6, the answer is still what? Okay, your nickname was 참나, okay? 참나 Lily. I mean 참나 Lydia.
Yes, so rad 2 over 2. Now we're doing the next one. Cosine pi over 6. Oh.
Cosine what?
Wait, never mind. That's rad 3 over 2.
You guys.
Please excuse our brain.
You guys, get it right. Cosine pi over 6 is what?
Rad 3 over 2.
Is it positive or negative?
Positive.
Yeah, so when you do a trig problem, you have so many things to think about. What quadrant am I in? What's my reference angle? Is it positive or negative? Okay. All right, tangent 5 pi over 4. What quadrant are we in if we're at 5 pi over 4?
Third.
Yes. Okay, so 1 pi over 4, 2 pi, 3 pi, 4 pi, 5 pi over 4. Okay, the reference angle is pi over what?
4.
Pi over 4, and tangent of pi over 4 is? You guys, man, you have to see
Rad 3
the
over
chart.
3? Yeah, which is 1.
You have to see the chart in your brain.
Yes, rad 3 over 3.
Do not see the chart in your brain. This chart right here. Tangent of pi over 4 is what?
1.
It's 1.
Wait, so tangent 5 pi over 4
Lydia?
is 6? 5? I was just doodling. So 5.
Okay,
wait, is it 5?
How do
No, the answer is negative 1.
Ooh, look at that. I'm gonna copy it so I can paste it right over here so I don't have to keep scrolling up. How do I put it back on though? Paste, here it is. Oh, look at that.
You got Lydia's head.
Okay.
Wait. So, oh, we're looking for coordinate,
Yeah.
not distance.
No.
Okay. Just need to get that straight.
Ah.
Uh-oh.
All right, you see it?
No, I don't see it.
Oh, I see a C.
Oh, yes, I see it.
And COT.
All right, do the next three.
Cosecant 5 pi. Wait, cosecant is sine, isn't it?
1/3.
And 3 pi over 3 is our reference angle. So, what quadrant are we in? We are in quadrant.
Okay, so now for cosecant, you can go like this. 1 over
Quadrant 4.
sine of 5 pi over what? 3.
3.
Now you can do it that way, or whatever you get for sine 5 pi over 3, just what?
Put it under 1.
Yeah. But anyways, just start it like this. Okay, so what quadrant are we in for 5 pi over 3?
The 5th.
The 5th? There's no 5th quadrant. There's only 4 quadrants.
The fourth.
The fourth quadrant. And in case one of you don't know, this is 1/3, 2/3, 3/3, 4/3, and what?
5/3.
5/3. 5 pi over 3 is right over there. Okay, so what's my reference angle? Pi
60.
over what?
Oh, pi over 3.
Yeah, again, guys, get used to just sticking with radian measure. Yeah, okay. But you know, it's good to tell yourself, yeah, it is 60. Okay, so what is the sine value of something that has pi over 3?
Rad 3 over 2.
Yes, so rad 3 over 2, but is it negative or positive?
It's negative.
Negative. So the final answer is -2 over rad what?
3.
Rad 3, but do we leave our answer with radicals on the denominator?
Wait. So,
No.
wait, no, isn't it?
So we have to multiply this by what?
1.
So we have to multiply by rad 3 over rad what? 3? You get it? There it is. That's your final answer, okay? You've rationalized the denominator. Okay, I'm kind of hungry. I'm going to eat something, okay? So, eat this. No, I can't talk right now because I have food in my mouth.
Wait.
So why did you do number 14 while I eat? How about I try to teach the whole lesson by keeping this thing in my mouth without chewing on it?
It's 45. 45 over 4. Cosine I over 2 over 2. Wait, why would you flip it?
Because it's not cosine, it's secant.
Because 1 over rad 2 over 2 is secant.
Yeah.
Okay, so look, write it like this. 1 over cosine pi over 4, 1 over rad 2 over 2. Got it? And then 2 over rad 2.
Wait, because it's already secant if you write it as 1 over cosine pi over 4.
Yeah, but when you have a fraction
1 over cosine. Okay, and this right here is this right what? See? It's on the denominator. And then you flip it.
Multiply it. 2
and
rad
this is
2.
what? 2 rad 2 over 2,
so it'd be
which is
1,
rad what?
So it would be rad 2 over 2.
We need another one because I'm hungry. This is so boring. It's so easy to work with. You guys are having such a hard time.
Or
All right. So bored. Oh my gosh. Can we do something a little bit harder than this? Can we just move on with our life?
tangent
All right, try this
4
one.
pi over 3 and tangent negative. Wait. Tangent is rod 3 over 3 negative 60.
All right, Lily. Come on. Come on, Lily. Hurry up. Lily. Okay, so this is going to be 1 over tangent 4 pi over 3. Okay, what quadrant are we in? Now, again, if you always get stuck, which in the beginning, it's understandable that you have no idea where you are on the unit circle. Okay, you can always draw this little cross because the cross represents Jesus Christ and we're asking Jesus Christ for help. Okay, the denominator means how many spaces or how many sections you're going to block off, cut off on the upper part of or upper or lower part of the graph. So see it? Wait here, let me do this. 1/3 and what? See, this is 1/3. This is 1/3. This is 1/3. Yeah, just cutting it into thirds. So you want to count off 4 what? 4 thirds. So we go 1/3, 2/3, 3/3, and
4/3.
4 thirds. Okay, so 4 pi over 3 is in quadrant 3. Now, in quadrant 3, are the tangent values positive or negative?
Positive.
Yeah, because it's going to be negative over negative, right?
Yeah.
Okay. So what is it? What is the value at tangent 4? What is the value of tangent pi over what? Pi over 3. Get it?
Rad 3. 3 over 3. No, it's not just rad 3.
It's just rad what? Rad
3.
3.
I thought it was. Wait, check.
You check.
Oh, it's just
Obviously,
rad 3.
I
It is
know
rad
it.
3
You
over
don't. I
3.
don't need to check. You need to check.
No, rad 3 is the bottom one.
Yeah.
Oh. Where? Oh.
Pi over 3 is the bottom one.
You have to memorize the chart or write it down somewhere and keep looking at it until you memorize it. You have to see it in your brains. Okay. All right. Let's move on. Now here. Number 16. The question is, if that's the value you're given, what quadrant are you in? If the cosine values are, now remember, anything that's above 0 just means it's positive. See? That means this is positive. Tangent, if it's less than 0, that means tangents are what? Negative. Well, what quadrant are we in for that to happen? Well,
1? No, 2. 2 and...
it cannot be 2. Oh my goodness.
1 and 4? For cosine?
No.
Yes. Okay, first of all, which quadrants is cosine values always positive? 1 and what?
4.
1 and 4. Okay, so again, cosine values are positive. Cosine values here are what?
Positive.
Now the question is, what quadrants are tangent negative?
4.
Quadrants 2
Oh.
and quadrants what?
4.
4. So where do they both agree? In quadrant 4. Does that make sense? For this to be true, they have to be in quadrant 4. Okay?
Yep.
Ian, did you just yawn?
Yes.
It means your brain is actually really trying hard. Okay? All right. Number 17. What quadrant are you in?
No. Negative side. Okay, so does that mean that tangent pi over 6 equals sine pi over 6 over cosine pi over 6?
Wait, I don't know what you just said.
Because you know how tangent equals x over y?
Y over x.
So tangent pi over 3 equals sine pi over 3 over cosine pi over 3.
Yes, very good. And then it'll
Okay.
simplify into rad 3 over
3.
All right, what quadrant is number 17 then?
1, 3.
What? Lydia, what did you say?
3.
1.
Okay, Lydia says 1.
Lydia,
Ian
what
says-
quadrants? Both are negatives.
Ian says...
Both are negatives.
Oh. I read
Ian
the sign
says it's
wrong.
negative. Lily, what do you say? Just write it down.
You ugly. You ugly.
You ugly? Okay, it's quadrant 3 because
Yeah.
sine. Okay, cosecant is a y, 1 over y coordinate, and secant is a 1 over cosine, right? So both are negative. In quadrant 3, you have cos x and y both being negative. Okay, zoom out. Pick your sections here. All right, try number 1, 2, and 3. Okay, try 1, 2, and 3. I'll give you a few seconds.
0. No.
Ian, can you please not talk? You're confusing me.
Okay.
Gosh, Lydia. Take a chill pill, dude. All right.
White coyotes.
What'd you get for cosine 0?
0.
3. Oh, I'm doing number 2. Sorry, I got 0.
What's number 1?
Wait.
Wait,
0.
what?
0.
0.
Oh. It's 1. What do you mean 0? It's 1.
X value. Oh yeah! Oh my gosh.
Okay, look.
I kind of just skipped that one.
The radius is sitting at 0 degrees, right? What is that coordinate right there? 1, comma what? Cosine values are x coordinates. So what's the x coordinate right there? 1. Okay, stick to this one again. So what's cosine of 90 degrees then?
0.
-1. Wait, no, I was thinking 180 degrees. Sorry. 0.
Lydia, what?
I'm so tired.
Cosine of 90 is what?
0.
Okay, what's cosine of 180?
-1.
-1. What's cosine of 270 degrees?
0.
Lydia, what is it? 270 is right here, going all the way around. It's 0. Okay, what's cosine of 360 degrees?
1.
1. What's sine of 90 degrees?
1.
What's sine of 0?
0.
0. What's sine of 180?
-0.
Negative 0. Which one is it?
0.
0. What's sine of 270 degrees?
-1.
-1. Okay, does that make sense now?
Yes.
Yes.
My goodness. All right, what's number 2?
Negative rad 3 over 3.
3. No,
Negative
No,
rad
negative.
3 over-
Tangent is positive in quadrant
Oh
3.
yeah.
What is it?
Negative. No, no.
rad
rad
3 over 3.
Negative rad 3 over
That's
3.
2.
Oh. Negative rad 3 over 3. Okay.
Don't do trigonometry after
All right.
Sunday.
Secant pi over 6. What's that?
2 rad 3
I
over
haven't done
3.
this one yet.
Well, this would be cosine of what? Oh, you haven't done it yet? Hurry up, finish.
Right.
Trigonometry is kind of harsh. Well, just no, it's not. It's just a lot to think about at the
Yeah,
same
you have to-
time.
Your brain is doing backflips as you're trying to answer just one question. Okay, well, are you done?
Faster, Lynn.
Okay, what is it?
Trying. 2 rad 3 over 3.
2 rad 3 over 3.
So cosine pi over 6 is rad 3 over 2, right? And you flip it.
Yep.
It's 2 over rad 3, so this is 2 rad 3 over
3.
3. Okay, next 3. 4, 5, 6, go. Okay. Back to the program. Cosecant pi over 2, which is part.
Wait.
We're not done.
How can you not be done? That does not make sense. How can you
0,
not?
-1. Rise over run, -1 over 0.
Wait, which
What?
number are you guys doing?
4, 5, and 6.
Wait, just do 4. What's 4? What's 4?
1.
1.
Okay.
Oh,
good.
yeah.
What's cotangent 3 pi over 4?
Working on it.
-1.
Hmm?
-1.
Okay. It's negative tangent over pi over what?
Wait, in the second quadrant is tangent negative?
Yes.
What do you think?
Because rise over run, one of them has to be positive.
Oh, yeah.
Okay, that equals negative 2 over rad 2, which is negative 2 rad 2 over 2, which is negative rad what?
2.
2. Okay,
What?
Number 6. Tangent 270.
Wait, which one are you on?
6.
Tangent pi over 4.
Tangent 270.
Wait. Isn't tangent pi over 4 1?
Right, where is 270?
Yeah, isn't it -1?
Right here. This is 0, -1, right?
Yeah. So it's -1. You said it was negative rad 2.
No,
Undefined.
Wait, Appa,
Seriously?
isn't it problem 5 -1?
No, it isn't because it's rise over
Oh
run.
my goodness, yes. Sorry.
It's 1
No.
over 0. Negative 1 over 0.
No, we're talking about 5 minutes.
Okay.
That was problem 6.
Yes.
Yes.
Okay.
No,
you know
you're
what?
doing
Let me go
problem
back.
5.
I did. Okay. I did number 5 totally wrong. What was I thinking?
Yes.
Okay. So it's
Tangent
basically
of pi over
negative
4
1.
is 1. Yes.
Okay. Tangent 270. Here, let me just start again.
Wait, is there a hole
Tangent.
in the circle?
Tangent is Sine over cosine, right? So what's sine 270 over cosine of what? 270. Well, sine 270, sine values are negative
0.
1, 0.
Indefinite.
Undefined. Undefinite. Okay. I feel like Lily is going crazy. I bet she's like... And what's funny? If she starts talking to you guys, thinking she's actually online with you guys, and then she realizes, like, she's like, Lydia, Ian, can you hear me? Okay, so at least she can rewind, you know. Did I hit record? Oh yeah, it's recording. Okay, I hope the sound is coming through. What if the sound is not coming through? That would be really sad. Because I'm not going to make another recording. I'm just going to have her watch a silent tutoring video. Okay, what's this one? Now, when you see the negative right here, that means you're going to go clockwise, okay?
That's what I thought.
So
What?
here's negative pi over 3. Negative
What?
2 pi over 3.
Oh
3
no.
pi over 3. And then what? Negative 4 pi over 3 is over there. So you're going to go like this. That's negative angle or negative radians. You're just going backwards.
Okay.
Okay, so, but you know your reference angle. It's the bottom number. It's 3, right?
Okay.
So in quadrant
Negative.
2, okay, you guys do it. What is it?
Negative pi over 3 cotangent 3 rad 1 over rad 3.
Okay, so first
Wait.
of all, always ask if it's going to be positive or negative. That's the first thing you want to figure out. In quadrant 2, tangent and cotangent values are
Negative.
negative. So you're going to put negative in the front. Okay.
So you don't pay attention to the negative radians when you're computing.
No,
in
negative
front of-
radian just means you're going to go this way.
Oh,
Positive
okay.
radians, you're going to go this way. See it?
Okay.
So
Negative.
the tangent, cotangent value, okay? And then here, I'll just go like this. 1 over negative tangent of pi over what? 3. Okay.
Is it
so-
positive 2 pi over 3?
No, it's not.
No.
Why is it positive? It's negative. We just said it's going to
No,
be
because
negative.
I found the negative one and then I changed it to a positive one.
What?
Oh, okay.
I figured out what it was if you go.
All right. What's tangent pi over 3 in our chart? Radical 3. There you go. So, but with the negative, it will be negative rad 3. So if you simplify it, it's negative rad 3 over 3. There you go. Oh man, Felix is crying really loud right now. Okay, what quadrant are we in?
Quadrant 2.
Wrong.
No, 3.
Okay, please try to use your brain once in a while.
3.
3, quadrant 3, okay?
Negative
going-
or positive.
1, 6, 2, 6, 3, 6, 4, 6, and what?
5.
Negative 5 pi over 6 is right there. Okay,
Secant is negatives.
so
So
this is
negative
basically a cosine value, right? So we're going to be negative.
1 over cosine pi
Yeah,
over
that-
6. Negative 1 over pi over 6 over 3 over 2. Negative 2 over pi 3. Negative 0. Oh yeah, sorry.
Okay, there's your answer. Got it?
Yes.
Number 9. Number 9.
Negative
You thought today was going to be a breeze.
sign is negative.
Yeah, what is this one? You're yawning because it's hard. I'm yawning because it's bored.
Wait, I can't. Negative rad 2 over Rad 2 over 2.
Wrong. Come on. I told you have to always ask, is the answer going to be a positive answer or a negative? Always nail that down first based on the
It's
quadrant.
negative.
Negative rad 2 over 2.
What quadrant are we in?
4.
Sign values are y coordinate values. In quadrant 4, you go down. It's going to be?
Negative.
Yes, negative.
That's what I said.
That's what we said.
That was our
Oh,
first.
okay,
That
I
was
didn't-
always our answer.
Okay, I didn't hear that. I just heard. Okay.
Negative
All right.
rad 2 over 2.
Negative rad 2 over 2. Okay. Last three. We'll just do one at a time. What's cosine of negative 270?
Oh,
Yes,
cosine of
Lydia. Oh, you're not raising your hand?
0.
Why would
0,
you take
1.
off your sweater
Negative
doing
1.
like
No,
this?
0, 1. 0 over 1. 0. 0.
What's your answer?
0.
Well, what did you say? 0 over what?
Wait, never mind.
No, it's right. 0, 1, right?
Wait, cosine. Cosine. Whoa. 1.
You're right. What? It's right here.
Yeah, but it's cosine. It's not
Cosine is your
tangent.
x coordinate. X coordinate.
Oh.
Wait, am I doing? Oh, I was doing the wrong one.
0.
Lydia, why are you
that's
doing the
why.
wrong one? We're on number 10. Do you not see the screen? 10. We're doing.
I wasn't looking at
Number-
the screen. I was trying to listen to
Why
you.
would you
and
not be
follow
looking at the
same
screen?
time.
This is called a virtual class. You look at the screen.
Oh, this is hilarious.
All right, number 11. What quadrant are we? I'm so tired of asking that question. Oh my gosh.
Quadrant 3.
What quadrant
Isn't
are we
it
at?
2?
Nah?
Oh, yes, it's quadrant
How can it be
2.
2?
It is.
I mean, yeah, you're right. It is. Okay. What's your reference angle in this case?
We're so tired.
30.
Hilarious.
Pi over 6.
Yes, 30 degrees. We're in degree mode, so you have to give your answer as degrees. Okay, so basically, is it going to be positive or negative?
Negative.
All right, so what's tangent of 30?
Rad 3 over 3.
Alexa just answered, what's tangent of 30? She said, rad 3 over 3.
Nice.
Oh. Alexa, what's tangent of 30 degrees? Oh, she's giving the decimal approximation. Guys, you cannot use Alexa or Siri, okay?
Remember that video?
Oh yeah.
John
What?
Moon?
You're like, oh, you just say it out loud, really loud, and then Siri hears it. Oh, it gave me the answer. Okay. Last one, number 12.
Quadrant. Or quadrant
What?
1.
What
1.
quadrant? Lydia, what quadrant are we in?
1.
No, I said Lydia. Is your name Lydia, Ian?
Yeah, 3. Wait, what? I said 3. 1.
What?
I'm at 1.
1. It's backwards. You're over here.
What?
That's negative 315 degrees,
Oh.
which is the same as 45 what?
Okay.
Degrees.
So it's going to be positive.
Oops.
Why just positive?
Wait, cosecant is sine?
1 over.
Yes, 1 over
Cosecant
sine.
is
So this is
sine,
1
right?
over
1
sine
over
of 45, which is
It's 2.
over 2 over 2. No, it's not just 2.
Yeah.
It's
Oh.
rad 2. I have a feeling for the homework you're going to get so many things wrong. And it's going to be because you're in the wrong quadrant. Okay.
I meant 1. I
So
was in the first
rad-
quadrant.
Rad 2 over 2.
Okay. Now, we got 4 minutes, so we need to learn something new. Okie dokie. Here we go. Okie dokie. Why doesn't this go up? Am I like out of space or something? That's never happened before. There it goes. Okay. So now, do you guys remember the Pythagorean theorem equals x squared plus y squared equals what?
R squared.
Well, okay,
That's the
technically it's
circle
a
formula.
squared plus b squared equals what?
C
C
squared.
squared. But because we're using a unit circle on an x and y coordinate grid, x will be the horizontal distance, y would be the vertical. So, and radius will always be a what?
Hypotenuse.
1, right?
Oh, okay.
Yeah, because we're using a unit circle. Got it?
Mhm.
Well, guess what? X is equal to what?
Cosine theta.
Y is equal to?
Sine of theta.
Wow, wow. So can we just do this? Cosine theta squared. Sine
Oh,
theta
no.
squared equals 1. Oh, look at that. Now we have cosine squared theta plus sine squared theta equals 1. We now have a trig version of the Pythagorean theorem.
That's great.
Oh, ho, ho! So this is, okay, by the way, you see when it says this parentheses squared, the shorthand form is cosine squared theta, okay?
Okay.
Later on, you'll see things like cosine theta squared, and the square only applies to the theta. But when you put the square in between right there, it's basically that. So when you write it out, you want to write it out like this. But when you do your operations, you want to think of it like what?
That.
Like that. Got it? Okay, now let's try something here, okay? So, you know, mathematicians are looking at this and thinking, how can we make life miserable for our little ones? Okay, so we're like, hey, don't we have the division property of equality? Yeah. So we can divide everything by whatever number we want, right? How about we divide everything by cosine squared theta, just for the sake of doing it, okay? Cosine squared theta, cosine squared what? Theta. Wow, what's cosine squared theta divided by cosine squared theta?
1.
Whoa, what's sine over cosine?
Tangent.
And what's 1 over cosine? That's?
Cosecant.
No, secant.
Secant. I get the
Whoa, what is this?
No.
What is this? Well, guess what? If you take a look over here, you have sine squared theta plus cosine theta equals 1. And then you have another version. 1 plus tangent squared theta equals what? Well, where did they get number 2 from? They got it from rule number 1. Simply by dividing both sides by cosine. How do you think they got this one?
Sine.
By sine, because 1 over sine is cosecant. Ah, okay. Now we'll discuss this more later. Okay, so work on your Dr. Chung's SAT tips, and then we'll recuperate and then work on this on Thursday. Signing off.
Goodbye, Lily.
Miserable. Ugh.